Today, we're going to understand the difference between normal VAR and Lognormal VAR in the simplest way possible, with real-life examples and zero complicated math. Let's start with normal VAR. In this method, we assume that returns follow a normal distribution, which is basically the bell-shaped curve you see in statistics. That curve is symmetric, so gains and losses behave nicely around the average, and we only need two things: the average return and the volatility. Because of this simple assumption, the calculation becomes very fast and easy, which is why banks and trading desks love it for daily risk reports. Imagine you have a portfolio worth 10 lakhs and the daily volatility is 2%. For a 95% confidence level, we multiply 2% by 1.65, which gives us about 3.3%. That means the worst expected daily loss is roughly 3.3% of the portfolio. In money terms, that's about 33,000 rupees. So the normal VAR says there's only a 5% chance you'll lose more than 33,000 tomorrow. Simple, clean, and quick. But here's the catch. The normal distribution assumes prices can move symmetrically and even go negative, which doesn't really make sense in real life. A stock price can't fall below zero, and markets crash more often than the bell curve predicts. So this model sometimes underestimates extreme losses. That's where low normal VAR comes in. Instead of assuming returns are normal, Lognormal VAR assumes log returns are normal, which makes prices normally distributed. In simple words, this means prices move in a compounding way rather than a straight line way. For example, if a stock drops 10% twice, it doesn't go from 100 to 80. It goes 100 to 90, then 90 to 81. That's multiplicative behavior, and lognormal models capture this much better. Also, prices can never go below zero, which makes the model more realistic. If we take the same 10 lakh portfolio with 2% volatility and calculate lognormal VAR, the loss comes out to around 32 to 33,000, very close to the normal VAR for small volatility. But when volatility is high or the time horizon is longer, the difference becomes bigger, and lognormal VAR gives more realistic results. That's why models like Black-Scholes and many option pricing methods rely on lognormal assumptions. So practically speaking, if you want something quick and easy for short-term daily risk, normal VAR works fine. But if you're dealing with longer horizons, derivatives, options, or highly volatile assets like commodities or crypto, long normal VAR is usually a better choice. If this made things clearer for you, you're already ahead of most students in risk management.